Alright, so here's a quick tutorial about quadratic functions. So what is a quadratic function? Well, by definition, it's a function that has the following form. F of x equals ax squared plus bx plus c. And this happens when a is not equal to 0. That's really important because if a was equal to 0, then you would just have a linear function, not a quadratic. The graph of a quadratic function forms a parabola. It's basically this U shape that's right here. If you notice a is greater than 0, if we were talking about in the standard form, it's ax squared plus bx plus c. Well, this a right here is greater than 0 because it's 1. As you can see, it's a little invisible 1 there. And it forms a little minimum on the bottom. If you notice, the values don't get any lower than this minimum right here. There's no values under here. It doesn't always have to form a U. It could form an upside down U as well. In this case, it's when a is less than 0. As you can see, there's a -1 in front of this x squared right here, and it forms a max. There's no values that can go higher than this up here. There's a symmetry to quadratic functions when they're graphs. So you have this parabola here, and right down the center of it, it's called an axis of symmetry. And to calculate this, you use the following equation: x equals -b over 2a. This is explained in a previous video of where this -b over 2a comes from. So if you want to check that out, that's definitely worth it. Now, the point where the axis of symmetry intersects the parabola, that point right here, is called a vertex. And the vertex has the formula of -b over 2a, which makes sense because it's the same x coordinate as the axis of symmetry. Only the y coordinate has the function, whatever this function of this parabola is, of the quadratic, you would just take the function as the input -b over 2a. So you would put the -b over 2a into the function to get the y. So that's your x right here, and this is your y for the vertex. There's certain forms, different forms you can have for quadratic functions. The first one is called standard form, and it's the one we used in the definition. F of x equals ax squared plus bx plus c when a is not equal to 0. There's also vertex form, which looks like this. It's a times the quantity x minus h squared plus k. And this h and this k actually represent the vertex. That's why it's called vertex form. So you kind of have it right in the equation there. Again, a is not equal to 0. If a was equal to 0 in this case, you would just have a flat line, basically. Horizontal line. Alright, in factored form, last but not least here, it's in this kind of form where it's a times the quantity x plus m times the quantity x plus n. Again, with a not equal to 0. And what's great about having it this way is that -m, 0, and -n0 represent the x-intercepts. So you have the x-intercept right in the equation, right in the function itself. Alright, calculating the key features. There's certain key features that you want to look at with quadratics. The first one we're going to look at is the vertex, and from standard form, this is how we would find the vertex. So you have f of x equals ax squared plus bx plus c. As we stated before, x is equal to the -b over 2a, and y would just be whatever you put in this -b over 2a back into the function to calculate the y. So that's how you would find the x and the y, which is basically covered a couple slides ago. Alright, for x-intercepts from the standard form, you would have the same standard form to start with, but this time you know, because it's an x-intercept, f of x has to be equal to 0. Y is equal to 0 for the x-intercepts, by definition. So I put the 0 in for f of x right here, so 0 equals ax squared plus bx plus c. So I just put the 0, substituted it in for f of x. From there, you can use the quadratic formula, which was explained in a previous video. So if you want to see where this equation comes from, it's explained earlier. And what you essentially did is you found the x. So this is going to be your x-coordinate, this whole equation right here. And your y is going to be this f of x equals 0. So y would just be equal to 0 in this case. So you have your x and you have your y. And it's really important to note that x-intercepts have to be a coordinate. Okay, it's a point in which the intersection happens. So it has to be a coordinate, so it has to be, x, y coordinate. Last but not least, we have the y-intercept from standard form. So what you do for y-intercept, you know it intersects the x-axis at 0, so you would just be inputting 0 in for the x right here. So I'm doing f of 0 times a, instead of a times x, it's a times 0 squared, plus b times 0 plus c. And if you notice that this is just going to cancel out to 0, the b is going to cancel out to 0, and you're going to end up with f of 0 equals c. That's going to be your y term for for the coordinate. Again, the y-intercept is also going to be a coordinate just like x-intercept. The x-intercept is going to be 0, as you can see right up here. That's what we inputted as 0. So then you have your x and your y coordinate for calculating y-intercepts. Hopefully that explains quadratic functions a little bit better. If you have any questions, let me know.